Hey guys, today we're going to be talking about direct variation. So there's a few different ways you can see direct variation. You can see it in a graph, in a table, in an equation, and just with points. So kind of to start at the beginning, we've got our definition here. And with our definition, it says two quantities, x and y, show direct variation when y equals kx. So k, if you think back to like unit rate, k is your unit rate. So whatever you do to x, you times it by your unit rate to get to y. And k cannot equal 0. And the graph has to pass through the origin. So see at this picture here, y equals 2x. It goes through the origin, it causes a straight line, and it's proportional because you multiply all of it, every point, every x by 2. So looking down here at the bottom, or A right here, we have x and we have y. So notice we don't have necessarily going through 0, 0, so it's not a direct variation. We also notice what are you doing to x to get to y? So what are you doing to 2 to get to 0? What are you doing to 3 to get to 2? What are you doing from 4 to get to 4? So it does cause a straight line, but it does not show direct variation because it's not going through 0, 0. So looking over here at this A, we have an equation. What you basically need to do is get y by itself. So you've got to kind of solve the equation a little bit and move things to the other side. So to get rid of this plus 1, we're going to minus 1 on both sides. So our equation equals y equals 2x minus 1. And again, if we graph that, that's not going to go through 0, 0, because if you plug in 0 for x, you're going to multiply it by 2 and get 0, but then you have to minus 1. So y is not going to be 0, 0, so it is not direct variation. So looking at the next one, we have 1/2 y equals x. Again, we want y by itself, so we got to get rid of that 1/2. So we're going to multiply by the reciprocal on both sides, so we're going to multiply by 2. So we get y equals 2x, which then is direct variation because if you plug in 0 for x, you're going to get 0 for y. And 2 is your constant rate, which makes it then proportional. So now let's look at a table, okay? And we're going to see if it is going to be proportional or not. Remember, these are the things it must have. It must go through 0, 0, be proportional, and make a straight line. So if you kind of want to think through your check boxes of, is it this, is it this, is it this, is it this? If it has all three, it is direct variation. So for this one, let's look. It doesn't have 0, 0 as a point on here, so we'll see if it will work in a second. So kind of think through, does x, what do I do to x to get to y? So when I say do to x to get to y, that means what do you multiply x to get to y? There's some that you could add to x to get to y, but again, that's not going to be direct variation. So here our equation is going to be y equals 2x. You multiply your x times 2 to get to your y. So if I plug in 0, I'm going to times it by 2 and get 0, 0. So it is direct variation because it goes through 0, 0. And it's proportional. I'm kind of shortening this. You can write it more out in words just for the video. So looking at the next one, it does have a 0, 0. So we're going to check that off. That is one of our key things, but let's see if it's proportional. Is there anything I can times 1 to get to 1? Well, I guess I could times it by 1. So y would equal x, and that would work for our 2 to 2, but let's look at the negative 1, 1. So negative 1 times 1 isn't 1. So it is not proportional because it would not create that straight line. So it's not proportional. Okay, so I want you to pause the video here, and I want you to try number 3. Okay, so number 3 can be a little bit tricky because think about what you're multiplying x to get to y, or what are you doing to it? So you're actually doing y equals x divided by 2, right? When I say 2, I actually mean 4. Sorry about that. So again, you're dividing x divided by 4 to get to your y. So let's think about this. Remember, it has to be proportional. You have to have a k, a unit rate, and that's what you're multiplying it by. But is there something you're multiplying x to get to y? Actually, think about this. Could it be y equals 1/4 x? Yes, that makes it then proportional because you're multiplying it by 1/4. Always remember, you could multiply something by a fraction. And dividing by 4 is the same as multiplying it by 1/4. So, would it go through 0, 0? Yes, you plug in x, 0 for x, multiply it by 1/4, you're going to get 0 for y. So, as you can see here for this one, it is proportional because it would go through 0, 0, and it's proportional. Again, for you, I want you to write it out a little bit clearer and more of a complete sentence, but obviously for this video, just trying to save time without a stylus. So now let's look at 2 points, okay, or 4 points and see. If you want to draw the table, you totally can. Or think about still, what are you doing to x to get to y? Okay, so I do have a 0, 0. This is a similar problem to the one in the table. The 1 to 1, you would times it by 1. 1 to 2, you times it by 2. But not, oh, actually look at the -1, -1. Ooh, so is this proportional? Yes, think about what the equation would be. Y equals x. Because what are you multiplying it? What's your unit rate? Is 1. And it passes through 0, 0. So yes. Sorry, this is so messy. Let me erase this and fix that a little bit. So y equals 1x, and then it is proportional because you're multiplying it by 1. So for the next one, automatically I can see that 0, 0 is not going to be happening for this proportion, so I'm going to go ahead and circle no. And I can see, I'm going to kind of start looking, I like looking at my ones with zeros to figure out equations just because it kind of starts out a little easier. So I'm going to look at 0, 2. What do I do to 0 to get to 2? Well, I'm not going to multiply by anything, so that should automatically indicate to you it is not proportional. But what are you doing? You're adding. So it's y equals x plus 2. Again, we said if there's a plus or minus anything, it's not proportional. Okay, so for this one, it does not pass through 0, 0, and the equation is not equals y, it is not y equals unit rate x. So number 2 is not proportional. I want you to now pause the video and do number 3. Okay, so I want to see what you guys came up with. I hope that you got that it is not proportional because it's not going up at a consistent rate. So here you are multiplying by 2. Here you multiplied by 4, multiplied by 6, and you multiplied by 8. So again, not proportional. Our equation is not going to be y equals one number x. It would not pass necessarily. It could pass through 0, 0. We just don't know what the rest of the points would be. I would probably say no because it would be 1, 1. I would assume would be the other point. So it's not proportional and it does not pass through 0, 0. Make sure you have that correct answer on your paper. So it is not proportional. It does not pass through 0, 0. And it does not have a consistent rate. So now we're going to look at our equation. So we've looked at a table, we've looked at some graphs and some points, okay? So this first one should be pretty easy. Y equals 4x. Okay, sorry, that little line shouldn't be there. Y equals 4x. Is it proportional? Yes, y equals 4x. It goes through 0, 0, and it's proportional. I think this one originally was supposed to be y equals -4x, so I want to talk about that real quick. Think about it. It is going at a constant rate. Even though it's a negative, it's going to go in a negative direction. So instead of going from the third quadrant to the first quadrant, it's actually going to go the other direction from the second quadrant to the fourth quadrant. So it would kind of look like this in a negative direction. That's okay. It's still direct variation. It's still going to be proportional, and it's still going to go through 0, 0. So I want you to take a second and try number 5 through 9. I am going to walk you through them in a minute, but I want you to try them. I want you to see if you can manipulate the equations to get y equals unit rate x. Okay, so let's start by looking at number 5. Again, our y isn't by itself. So what do we do to both sides to get rid of it? You multiply by the reciprocal. So y ends up equaling, let me change colors here. Y ends up equaling 5 over 2x. That's fine. It's still going to be direct variation. You could change that to be a mixed number. Again, it's still a unit rate. You're still doing the same thing to both ones, so it is direct variation and it is going to pass through 0, 0. Number 6, what do we think? It is going to be a no. Automatically, you can see it with your plus 6. The unit rate was 3, which is great, but that plus 6 makes it not go through 0, 0, so not direct variation. Again, you should be explaining this on the line a little better and in more detail. So number 7 should look familiar to kind of one we did earlier. Remember, dividing by 2 is the same as multiplying by 1/2. So our equation can manipulate to be y equals 1/2 x. Again, a unit rate. So yes, this is going to be proportional and it is going to pass through 0, 0, and so it's direct variation. So looking at this one, x equals 0. So we don't even have a y in this situation, so it's not even going to be giving us an x or a y, doesn't show direct variation at all. This next one is just flipped around. So y equals 3x is the same thing, just flipped around. Our unit rate is 3, and it is going to go through 0, 0, and it's going to be proportional. And it's going to create a straight line. There's nothing else added or anything like that. So it is going to be proportional. So I hope this video helped you to understand and learn direct variation. In the next few days, we're going to be going a little bit deeper, but these are some basic introduction notes. So I hope you enjoyed this video.